Right, this is very similar to the previous example that we looked at. We've got two equations, our parametric equations. This time the parameter is t. Okay, so we're working with t. Now again, I can see I've got sine and cos. I'm going to link those together by using the Pythagorean identity, this time in terms of t. Sine squared t plus cos squared t equals 1. What I'm then going to do is straight up here, I'm actually going to solve each of these equations for sine t and cos t. 3 goes over, x minus 3, divide by 3. Solving for cos t, 2 goes over. Now in this case, this is a negative, so we'd be dividing by negative 2. Okay, so that's the idea. Now what we're going to do is, you can see here that this is a little bit different to what we had before, but we'll still do the same kind of idea. So I'm going to take my equation 1 and I'm going to this one here, call that 2. I'm going to substitute in 1 and 2 into my Pythagorean identity. So we're going to put in the sine part. That's sine of t, but it's supposed to be squared. I'm going to put in the cos part, and that's going to be squared as well, equals 1. Okay, now this is where it becomes a little bit different, because you can see here with the squaring that you're going to end up with that negative actually cancelling, so I should say becoming positive. So we're going to have x minus 3 squared. I'm just going to expand the bottom here, so this is 9. I'm going to leave the top bracket as it is with the square the bottom, which gives me a 4, equals 1. Now this is not a circle, because you can see that the two lines under here, the two denominators, are different. This is actually an ellipse. And it is an ellipse because we have these two things, which are effectively like a radius in each direction. They're what are called major and minor axes. So we've got these two different lengths here. Essentially, this one, the x, that tells us like a little radius in, roughly speaking, in the x direction is going to be 3 from a center. And this one here, because this is to do with y, this is the up and down, it tells us like the radius in the up and down direction is 2. Okay, so we also need to know what our center is. So our center, remember, is always the opposites here. So at x equals 3 and at y equals 2. So if we wanted to sketch this just to get an idea, it does just tell us to describe the graph, but just so you can see what it looks like, I'm just going to draw it nice and quickly for you. It's a bit rough. So we've got 3, 2 is our center. We've got in each direction we're going up by 2. We're going to be touching. And then up and down, I should say. And then left and right we're going to go 3. 1, 2, 3. 1, 2, 3. This particular ellipse is actually, I suppose, wider than it is tall. And when you're sketching these, try not to get any points. It's a bit pointy on that side, but try not to get any points happening. So with this ellipse, if we label everything nice and quick, we've got adding 2 in each direction here. This is going to be 3, 4. This is going to be 3, 0. Adding 2 in each direction, and then adding 3 in this direction. We're going to be up at 6, 2. Taking 3, we're going to be at 0, 2. So this is our ellipse. You can see we've got our center, we've got our shape, and we've got all of that by using these parametric equations. Remember, these two equations here are the parametric equations, and we've converted them into this format here, and this format in the box is our Cartesian format.